Let us see the problem statement. A simply supported prestressed concrete beam of rectangular cross section having a span of 8 meter is prestressed with an effective prestressing force of 600 kilonewton. The eccentricity of the prestressing tendon is 0 at support and varies linearly to a value of E at the midspan. In order to balance an external concentrated load of 12 kilonewton applied at the midspan, the required value of E in mm round off to the nearest integer of the tendon is. It was a 2-mark question in GATE 2020 examination. Let us note down the given data. The span of the beam L is 8 meter. The effective prestressing force on the beam is 600 kilonewton. The eccentricity of the prestressing tendon at support is 0 and the eccentricity of the tendon at midspan is E. The imposed concentrated load on the beam is WL equal to 12 kilonewton. Let us find out the objective. The objective is to determine the eccentricity of the prestressing tendon at the midspan section to balance the external concentrated load. So we have a prestressed concrete beam which is simply supported with a span of 8 meter and the prestressing force of 600 kilonewton with an eccentricity of 0 at the support, which linearly varies to E at the midspan and again linearly varies to 0 at the another support. It is subjected to a central point load of magnitude 12 kilonewton. We have to determine the eccentricity, which will give an equal and opposite force to balance the 12 kilonewton external force. Let us calculate the load and the moments due to load. The moment due to live load at the midspan section, which can be designated as ML, is equal to WL by 4 as the member is subjected to a central point load and the member is simply supported. So if you put the value of load and the span, the moment due to live load is 24 kilonewton per meter. The moment due to prestressing force at the midspan section can be calculated by multiplying the prestressing force with its eccentricity. Therefore, the moment is equal to P into E. For load balancing, the bending effect of the applied concentrated load and prestressing force shall create similar bending stress in opposite sense. Therefore, the bending stress due to live load equal to bending stress due to prestress. If we multiply the equation by Z on either side, we get the bending moment due to live load equal to bending moment due to prestressing force. Therefore, putting the values of the moments and the prestressing force, we get 24 into 10 raised to 6, that is moment due to live load, equal to 600 into 10 raised to 3, which is prestressing force into the eccentricity at midspan. And we get the eccentricity at midspan equal to 40 mm, which is the required answer.